Hey everyone, welcome back. In this video, I'm going to go through how to use the process analyzer, and I'm going to do this using model 5-4. So I have a copy of 5-4 here. Let's open it. Now, this is the same model that we created in an earlier video, but I just cleaned it up and made it look pretty. To refresh your memory, this is an inventory control system model at a company called Widgets by Bucky. They sell widgets. Their customers arrive, order anywhere between 1 and 4 widgets, and then they leave. And then once the inventory level gets down to a certain minimum threshold called little s, Bucky places a reorder to restock up to a maximum level called big S. In the original version of this model, starting inventory is 60, little s is 20, and big S is 40. And then the metric that Bucky is interested in is the average total operating cost per day. This cost is made up of the ordering costs. That's the amount it takes to restock. So that's $32 plus $3 per widget. Holding costs of $1 per widget per day, and shortage or back order costs of $5 per widget per day. So let me just go and check and make sure the run parameters are okay. So we're going to run one replication for 120-ish days, okay? So let's just run the model. I'm going to press play. And we can actually just fast forward to the end. No, I don't need to see the results. Now that the model has run at least once, if we go back to this folder, we have all of these files that have been created. And the file that I want to draw your attention to is this file. This is the P file, the program file, and this program file contains all of the code needed to run the simulation without any extra features like animation or report generation or anything like that. So let's go back to Arena, and we can go to Tools, Process Analyzer. Okay. So what Process Analyzer allows us to do is to build an experiment with our model where we can change some specified control variables and then see the effect on some specified response variables. So let's do this. We can create a new project and we can double click here to add a scenario. Let's just leave the name as it is, but we need to select the program file from model 5-4. Okay. Okay. And we can define our controls. So let's choose the number of replicates because this allows us to control the number of trials of our experiment. And we can also choose any variables that we defined in the model. So let's choose little s and big S. Now the response that we're interested in is the average total operating cost per day. Okay, and this is money, so let's just make it 2 decimal places. And then we can run this experiment 5 times. We're going to select this row and hit play. Oh, we need to save this first, okay? Yes. Okay, let's try this again. And here we can see our response. We can also see how this response is broken down if we add more response variables. So let's add these. And these metrics were also calculated when the simulation ran, even though I didn't ask to have it displayed here. So let's just create some other scenarios and play with these levels a bit. We can try, well, okay. Oh, and also if you're comparing 2 different scenarios of 2 different models, these don't need to be the same P file, but you do have to make sure that your controls exist with the same name in both models, and then your response variables exist with the same names in both models. Okay, so let's just change these controls. And this dialog box just says that if we change these controls, then the responses from previous runs will be deleted. That's fine. Okay, so let's try some different values of little s, maybe 10, 20, 30. And then let's choose our big S so that the difference between the two is either 10, 20, or 30. And then to be consistent, let's run all of these 5 times. And now we can highlight all these rows and press play. So now that we've run our experiments, we can see our responses here. But keep in mind that these are the means across the 5 replicates, and we can't make decisions based on just point estimates, but we can look at some confidence intervals and make some statistical comparisons, even with a small sample size. So we can do this pretty easily by highlighting this response variable. This is the response variable we want to compare, and then we can insert a chart. So let's choose a box and whisker chart. Yes, yes, we want to look at these scenarios. And since our response is cost, smaller is better. Okay, and here we go, our plot. As you can clearly see, this answers all of our questions. Just kidding, it's tiny and awkward. Let's click here and view the plot in a normal size. So here we can see that Process Analyzer has identified these scenarios as the best scenarios, but it's unable to distinguish between them. Keep in mind, this is based on a sample size of 5. So let's go back and try to run this again with a larger sample size. Let's try a sample size of 30. Press play. So actually that first scenario, scenario 1, it was originally 10 and 20, it was so small that in replication 12 of this scenario, the system got completely overloaded and I had to change this a little bit, but here we go. We can still look at this. So yes, yes, smaller is better. Okay. And now if we go to view the plots, the first plot is the one from earlier, but here on the second page, so these are the recommended levels if Bucky wants to reduce his costs. Now, the OR people in the room might be asking, how do we know that these are optimal levels? We just picked some arbitrary numbers. And yes, that is true. There are actually other tools in Arena that we can use to try to find optimal levels, but that's outside the scope of what we cover in our lab. We just don't have time for everything. But Process Analyzer is a pretty powerful tool by itself, and it can be really, really nice and very good when comparing 2 different systems or when testing out our hypotheses on what might improve a system. So I hope you found this video helpful, and I will see you guys all next time. Bye.